I want to talk about domain-specific languages today. If I had a question for you and it said, what is the most expressive language? More often than not, the answer that you'll give me is the mother tongue. Well, because we've grown up with that language and that's what we speak in. What is the most effective language of communication? Well, one that allows us to express. Before I take the details of how do languages become expressive and effective, I want to take a journey of how do languages actually evolve. Here's a picture. It is probably, you can guess, it's a cave. There is a hunter, there are animals. But the bigger question here is, what did you see? Do you see art or do you see data? It's one of the most confusing questions that has to be answered. What came first? Was it a need of expression or was it a need of communication? Or one led to the other, one would never know. The interesting bit here is when I show you this photograph, you can interpret it the way you like it. I may be seeing something that, hey, this is a zoo. You may be seeing something that, hey, this is a wildlife sanctuary. Somebody may be looking at this that, hey, this is interspecies communication. The interpretations could be far too many. The interesting thing here is when you look at certain pictures, and these pictures over the years have become meaningful things to us. An ox became A in Roman. Point being, you add interpretation rules and data starts to mean something. You know, it means to begin something because image was just a data. I could have interpreted it the way I liked it. You added certain rules to it, and now whether I read it or you read it or somebody else reads it, they're going to read the same thing. This is still at the character, at the image level. You combine all of these characters, these pictures together, and becomes a grammar. So what you're doing is you're defining grammar where data becomes now knowledge. A piece of text which was written 100 years ago, I read it, you read it, anybody in any country reads it, civilizations ahead of us are going to read it, they will get the exact same meaning. A quick brown fox jumped over the lazy dog. This means the exact same thing because there's a grammar to it. There are rules of reading it. And what it has done is it allows to carry that communication forward. So fair to say what language is. A language is a tool for domain curators. One may write poetry with it, one may write drama with it, one may write emails with it, or chat with it, or advertisement with it. It allows these domain curators to create content which is consumed by others. Even when I'm chatting, it's content. This slide, this is content which is being consumed. How does this content evolve? There is an advertisement here. This is a message to the millennials, a Chevrolet advertisement. All of these are pictures. They're no different from the pictures that I showed you at the first, the caveman picture. And the one who could interpret this, interpreted this. You and I probably can't interpret this. I can't. This probably would be 30 paragraphs, which I can't even debug right now. Case in point being that domain experts do not speak natural languages. As languages evolve, there's a natural tendency towards eliminating the amount of message overhead and getting to the point in a manner which is as crisp as this. This otherwise would have been like 5 paragraphs, but has been concised into a smaller, just a few characters of emoticons. So the whole journey from this till this is what I'm here to tell you. Why am I telling you all this? It's a bigger question. I'm Piyush Verma. I am CTO at Last9.io. We are a site reliability engineering platform, and we process events. We process lots and lots of kind of events from lots and lots of sources. Like I showed you the photo, I'm going to show you something else. What do you see when you look at this? Do you see art? Certainly not. Or do you see data? It's data. But what part of that data is important? Well, there is an event time which is important, a source IP address which is important, and then somewhere down there is hidden this instance ID which is important. These are rules of interpretation. When I look at the same data, I add these rules and it starts to mean something. You define a grammar or a parser and data starts becoming knowledge. And this is where we start introducing code. This is why, I mean, it's a Golang conference. This is why we start talking about what codes do. How will we do this? Well, a very simplistic function would look like, hey, there's a function which is called parse event. It accepts a bunch of bytes and it returns an event type. Inside of this, we will be defining a rules of, hey, read X, look for key Y, look for key Z, and then emit what an event should be. An event is what is homogeneous to the system, but what is coming in could be wide variety. We add more event types to it. I just showed you one event type. There could be many such. Well, there's a start instance, there's a stop instance, there's an update instance, add user to group 4, and there are 62 other such instances. Conditional blocks we've been taught is not the right way to go about it. So some of us will say that, fine, well, let's do a switch case. But 62 switch case, switch pollution is probably going to look something like this. Switch D event type, case this, case this, case that, 62 times. This is an ugly piece of code, which is still okay. I may still go ahead with it and say that, fine, I mean, it does the job. But what about if I have to now start adding different source types? I was just talking about AWS right now. Now I'm adding to it, there is Kubernetes events as well. How will I do this? Will I do another switch, which is I introduce a provider and I say that, hey, now the provider will do a switch. If it's of type CloudTrail, we do something. If it's of type K8s, we do something. This is resulting in a lot of switch pollution, right? Or I would say, well, Golang allows a beautiful way of interfaces. We should do that. We should declare a type provider with an interface which has a parse event, and anybody who does it. Now, inside of those parse events, there are still going to be nested blocks. I didn't really solve the problem. I just moved it to another piece of the code. It still remains. I still need to do a switch on a type because now I need to get the right type. So there'll be an if-else condition or a switch condition, same thing. Inside the parse, I may have another 62 types. Kubernetes also had around 28 types of events. This is all conditional block. While we're writing this in Go, one may very well raise a doubt that, look, this is not what it's designed for. You need function programming. Well, we could, but this is where I want to introduce something very interesting. Now, this is called an expression problem. An expression problem is a way of defining expressibility of a computer language. Just like we had expression for a human language, we have expression problem, which is the expressibility of a computer language as well. It simply states, can one add new cases? By new cases, we mean new types. It applies almost 1:1 to our case because CloudTrail is a type. Then we have Kubernetes, that's a type, and we have a bunch of other things as well. And be able to add new functions as well, where each function is typically just an event type here, without recompiling existing code and while retaining type safety. That is no cast here. That's a small print there which says no casting. When we move around these interfaces and we actually do inference, we are technically breaking this rule. So if you come to think of it at an expression problem, adding functions is very easy in function languages. There are types which are already defined. I can keep adding new functions to it. It's fairly easy, but adding types is not. On the other hand, on object-oriented languages, adding functions is not easy, but adding types is. You want to take a moment to grasp this. There's also a link in my slide, so you can actually read the paper. It's fairly straightforward and a worthy read. What we're saying here is, you got a base class, and you want to add new types which are derived from it. There's a car, and you have a Mazda, you have a Mitsubishi, you have a BMW. These are just new types of it. Fairly easy. But if you add something in the base class, either it's going to impact everything downstream, or everybody else has to know and change the code. This overhead of having to maintain so much code, and remember, we've started digressing into discussing languages here. All we wanted to do to begin was parse events, build an event parser. Our team has a bunch of domain experts who know AWS. They just want to extract that knowledge and build a system. They didn't want to go through this entire chain of, look, I got a JSON, I got a database. I want to get from point A to point B the fastest. There's another paper I want to point out here, which is called No Silver Bullet, which defines accidental complexity versus essential complexity. Accidental complexity is the overhead that code has to incur or programmers have to incur while solving a problem. Essential complexity is what your code has to go through. If you have to do 30 things, it's essential complexity. You can't get away from it. Accidental complexity is if I gave you a language and I removed the for loop from it, you will have to write that code 30 times. And it's almost inevitable that you will not introduce bugs in it. That's accidental complexity. As languages evolve, the reason why we keep adding standard libs, we keep adding functions, higher order functions, we keep adding the utilities. The reason is that we want to eliminate accidental complexity. We want to do a print, it should just do a print. I should not go through the byte array emission to a device, then I find it, then I connect via a driver and then do it. It's a waste of time. It's complexity that is going to result in bugs. Point we're making is more events is equal to new codes. More code is equal to new bugs. It's very straightforward. And again, getting back to the same part, domain experts don't speak natural languages. They speak a shorthand jargon. They just wanted, because when I show them on outside of a computer, hey, this is an event, they can point out to me that, hey, look, you want this, you want that, you want this field, you also want the IP address, you want the security group name, and all of these are important. But if the same has to be implemented, they need to go through a lot of code. To solve this, well, we said we'll introduce a DSL, a domain-specific language, which accepts configurations to parse events. And trust me, it is just 150 lines of code. Here's an event that parser. What we do here is we declared these keywords called edges. Now, edges is actually an array definition. What it does is it actually looks for these fields. So timestamp comes from a field called attached time in the JSON. Wherever it finds attached time, it will get inserted into the field called timestamp. And there's an equal to, which is a static string. So somebody wanted to provide a static string to it. So they just write a configuration which says equal to, and that gets associated. I want to take another example of look at create load balancer, parsing that. Same thing. Now we're going to add properties to it. We are going to add a property called DNS name. What is the value of DNS name? Look for anything called data. Inside data, look for a field called DNS name and provide that. Fairly straightforward. What is the label? Is a static string called DLB. What are we achieving with this? We are not creating a new build of our program or a binary every time we have a new event to add. Earlier, it was taking us a month for just onboarding 5 events. And those 5 months were full of regret and regressions. Now what it takes us is it took 7 days, all of 7 days, to add 55 new events, and which includes testing. Another important question here is that why did we write JSON? So why did we not pick up any other language? The reason for JSON is beautifully computer generated. A lot of people actually, we saw that they started generating this JSON as well, which makes it easy because they wanted some repeat pattern. They saw that, okay, look, there's a JSON, I can just generate it. The JSON is fed to a system without recompiling to an existing system. They get their data and job done. But did this DSL exist on day one? As we said, languages evolve, DSLs also evolve. And DSLs evolve again by the same goal of improving expressibility. The first thing that we think of, if you go back and if you recollect, what we didn't have there is any ability to add loops. So our DSL should also have the ability to add loops, because not having loops is one of the biggest limitations that people saw, that look, this is highly inexpressible because I cannot run an iteration over a similar looking pattern. We introduce for and do as the top level constructs, where what we say is for anything that came in response.items star, do this block. And the small resolution operator means that I have to look for this key, not at the top level, but inside the block. We go in, we find the source IP inside the block. Now inside this, I need to run another block because there's a nested array there. So we run another for loop where the key, where the iteration is happening over the tag set.items, And the key is now a double resolution operator. It didn't take us too much. People just picked this up. It became natural. And we could eliminate a lot of complexity because now people could just concisely write their parser. We need functions. It doesn't end there. Now we got to add repeated things that people were doing repeatedly. We thought it would be good to promote that as a first-class function, as a standard function itself. So in this case, there was a thing called revive edges. A revive edges was basically a set of repeat operations that were done over and over again. Along with the other keywords, we introduced a way to call a func and pass keyword arguments to it, and job done. How did this all come together? Let's look at this video here. This is a small demo of the work. Here's a configuration. This is the event. Now, if you look at this event, there is a lot of data in this event. Things like, here's a response element. Inside the response element, there is an instances set, which has items. There are multiple instances in it. So the whole event needs to be parsed. And think about the complexity. I'll have to do this for every single type of event out there and validate it as well, whether it is looking correct or not. Here's the items. Each one of these items is going to come out as a tag. Very important to know what this instance was. There's a group set, which refers to security group. There are network interfaces. This is full of information. Now, to parse this, I'll have to write a lot of code. We're going to just write a couple of configuration files here. The first one that we create is this configuration. We say a for loop of items. Do run these, find this instance ID inside that loop is equal to EC2, a static string, pull out the other events, their dynamic properties, look for a thing called tag set.items, nested operator, key value, do the same thing for edges. Just for more context, we're actually taking the data and inserting it into a relation manner where we can query this later. All of this is just to solve that problem. We declare this configuration and we don't have to recompile a code. All we have to do is we just need to write the configuration file. Similar thing goes for group set items. Same for network interfaces, save that, run the binary, provided the configuration, pass it the data file, which is the run instance event here. We run that. And boom, everything that we had to extract came out in a standard manner. These are the nodes that we wanted to create. They have all the properties down there, everything that we got extracted. Loops were created to produce edges. All of these are edges that we have to yield, which also have their own values. And that's it. So fair to say, we could conclude here saying that, hey, DSLs are awesome. Like they're really cool. So we should just write DSL. Well, they are. The only catch being every DSL lives long enough to be a general language or gets replaced by a newer DSL. What I mean by that is general purpose programming languages are moving towards solving more and more cases. They want to solve a web problem. They want to solve a mobile problem. DSL, on the other hand, is getting more and more specific to a domain. Like, what do I see a few months from now? How will this language, this DSL of ours evolve? This DSL will evolve that, hey, right now you're only parsing events, which are JSON. Can we also start doing it for another set of records, which are probably CSV, or there's a protobuf, etc.? It's becoming more and more specific. There may also be a requirement where we have to do some sanity check that if an X event is coming in, it depends on a Y. Do not insert an X before a Y comes in. It looks like it's doing a lot, but it is actually getting specific to a domain. So if you see what's happening here is in the pursuit of becoming applicable to the entire use case of a given domain, what is happening here is that the language itself is becoming more generic. So fair to say that a DSL lives long enough where it tries to solve every single use case of that domain and becomes a general purpose programming language. And when it does that, it has become a problem in itself. And I will be giving the same talk a couple of years from now, saying that we built a language and we replace it with another DSL. That's it. Thank you. That's a link to our monthly failure newsletter. You can have a look at it when you want it.
Okay, Piyush, thank you very much for the talk. This is a talk of exact type of exactly I like myself very much. The talk about ideas, not about bytes and chars and brackets and so on. We have in programming committee, we have some questions to you. The first one is, did you say using DSL make you writing less code, and as a result you have less bugs in your code?
So very good question. So writing DSLs enforces you to write the same set of functionalities.
Yeah.
You know, it's like a guardrails. You cannot, like on a highway when you're driving,
Yeah.
but like you have seen those guardrails, right? You cannot deviate far too away into the lanes. It keeps you within that bracket. Now let me give you an example. CSS is a DSL. SQL, programming language, the database languages that we've been using all along, that's a DSL, you know. Now the good part about DSL is, and this is, it's not exactly 1:1 translation, but you'll get my point when I say, you are telling somebody what to do, not how to do something, because the abstraction of the logic of the domain has been abstracted underneath. So you are saying, hey, deduct $1. If this was a DSL of a financial transaction, right?
Yeah.
You're not saying how to deduct $1. Like go here, add a float, subtract a float, then transfer, open a lock, create a temporary file or a temporary transaction. In case it fails, roll back. All of this has been abstracted. Now imagine if every time you had to write something and you had to go through this, you're going to result in bugs for sure, because humans are splendid at making mistakes when you ask them to do the same thing over and over again.
Yeah, that's true. The problem is then we have less code. Each bug in this code will provide bigger impact on our code. So how this could be solved?
Yes. Now it's a trade-off. You know, like usually in technology, the answer is always it depends. Now over here also I'll say is that it depends. Would you rather have 100 kinds of bugs or one same bug 100 times over? You see what I mean there, right? Now, if you know that, hey, this is the bug. If every time my pixel goes off by one, it's easy to fix it everywhere. And it's easy to catch as well. Why? Because if there is a bug with so many consumers of the DSL, it would be apparent faster than a remote scenario. Because when you, like, let me give you an example, right? Like in Java for 20 years, we had this bug, right? I forgot what that was, the floating point computation error. Like for 20 years, the bug was there and nobody noticed it. So with DSLs, because there's a limited set of 10, 20, 30 functions around the same set of operations, with every person doing it, using it on daily basis so much frequently, the bug would surface faster as well. So yes, while the surface area is smaller, the impact may be bigger, but it's going to surface up way faster because you can only do 10 type of things or 20 type of things. That's it. And an easy amount of testing can capture that.
Okay, thank you. We have some questions from the chat. First of all, are you using JSON because JSON for DSL because it's easy to use?
So good question. So JSON versus YAML versus HCL, you know, like I'm going to take an example of HashiCorp configuration language as well, you know, and I'm going to take an example of bad is a strong word, but I'm pretty sure when I say the name, you guys will understand my emotion. A DSL like Nginx. How many times have you struggled with Nginx DSL, right? And then you have something which is as easy to generate as a JSON, you know, like half the time I've seen that, you know, these days young programmers actually do not understand the difference at times between a dictionary and a JSON because it's been so interchangeably used. It has almost become a part of their daily lives. There's a hash map, there's a JSON. It almost looks the same. Now, it can be computer generated. So if you had stubs of smaller scripts, which could spit out a JSON, you can very well validate it. You can very well regenerate from your own other modules. That is one reason. And second is JSON versus any other configuration language, like YAML. Amazingly good when humans have to write it.
Yeah, that's true.
JSON amazingly well when computers have to write it, because now there's a fixed structure to it, right? And why JSON would work better than a YAML? Well, try writing a parser for Python versus Golang, and you'll understand how spacing can actually be a problem.
Another question. It seems that you are implementing, that you implemented XLST transformation mechanism, but you replaced XMLs with JSONs. You have some input. I didn't finish to read the question yet. Sorry, Piyush. You have some input JSON, then there is some rules declaration written also in JSON, and your application applies rules to the input data and generates output data. Is this really true, or is there some critical differences?
So yes, I was actually waiting for somebody to ask me this question that, hey, you have actually done an XSLT again. Now, I clearly respect you, sir, madam, whoever asked me this question. I clearly see that you are a programmer of the 2000s era, because not too many people speak about XSLTs these days. But yes, the inspiration, because I mean, those were amazing pieces of technology. They still are. They were widely used to solve these common problems, and they continue to be. So in a way, yes, the inspiration is the same. It's just that no longer XML is a standard choice of format of data exchange anymore. The input data, obviously, that we receive is from a JSON. And when this input data had to be parsed, amount of the Pythonic or other scripting code, like even if I would go a JQ route, right? Like, hey, JQ would do this, JQ would do that. The amount of unnecessary context that had to actually go in was insane. And on top of that, why we did a JSON? Because writing test harnesses around it was easier. Like input is JSON, output is JSON. So the intermediate configuration, well, that could be JSON as well. Like why should I reinvent a new language just for an intermediate step? Does that answer the question?
For me, yes.
For the audience?
Not for the original question after, Kirill Yanikin. I'm sorry, I couldn't pronounce it in Russia because it is in Latin language. Anyway, okay. Another question from the audience. Do you think your DSL is still comfortable and bug-free when you decide to use functions and loops in your DSL? I think you replaced cognitive complexity with code from the code to DSL. Yeah, that's probably true. Okay, that's not a question to me, but to you. So
no, go ahead. I want to hear what you're going to say. Go ahead, please.
That's a difference between declarative and imperative. I don't know how to pronounce it in English because
imperative.
Yeah, imperative languages.
Yes.
You usually don't have loops in declarative and languages because of this problem. Correct.
And so you have a very valid point here. Like I think that's the part that I was trying to cover in the whole journey of DSLs. I would start with my last slide. Every DSL after a point of time is going to become very complicated. It's the natural movement of a DSL, because let's say if you and I were to communicate right now, and I said that because we understand, we're not going to use pronouns. We're only going to use proper nouns. No him, no she, no words like that. We are going to address each other with proper nouns. What it does, it eliminates ambiguity. A good side. What it does on the bad side is, because we have been conditioned in a certain way, we're going to find that that constructs very limiting, because we have been programmed. We have been speaking so many languages where we say it's, his, hers. These words have been a part of our sentences. We have been conditioned to use it that way. But if I eliminate that, the essence of you to speak that freely will go away and you'll find it limiting. And we'll keep saying, okay, we're not going to introduce 3 genders, we'll only introduce 2 genders, male and female, and let's allow that. You see how we're drifting into it. And every DSL also gets into this. Now, going back to the original question, why did we write a DSL? Or why do we rather write a DSL at all? Because I'm seeing a lot of repeat code. I see that every engineer out there is actually going through the same process before they have finally evaluated, this is a field in the JSON that I want. How do I short circuit this line of theirs where they have to write 10 lines of code and another 10 lines of testing code and a cumulative sum of 2 hours before they finally tell that, okay, I found the right JSON field that I needed to extract from the source data. This 20 minutes of time is very valuable when you multiply it by so many events that need to be parsed with so much diversity. That was the reason. But when you do that, they say, oh, but I have to repeat this so many times now. The original promise of yours was to eliminate repetition, but now I see myself repeating another thing. So they ask for it that, hey, can I eliminate this repetition as well? So you say, okay, let me give you a for loop. So the for loop here is actually not a general purpose for loop. It's actually a loop just provided so that you can eliminate your own DSL. So the DSL is actually getting sharper or narrower, the way you want to look at it. One could say that, hey, this is getting better, or it's only getting more limited and specific to the context.
Yeah. Okay, thank you. The next question is already answered. What about using YAML instead of JSON? That's already covered. And another one is also covered. It looks like we are talking about declarative programming as well as a reinvention of interpreters, isn't it? Yes.
You could say, because, I mean, what is an interpreter, right? An interpreter's job is it takes a very high order language and then it has to interpret it into a lower language. Now, I mean, yes, this opens up the box of what are transpilers, etc. But I'm not going to go there. So let's just assume that for a while we're saying that, look, language X needs to be interpreted into another language that the system understands. Now, Python gets interpreted because one could say that. So is that a DSL? Well, for all definition purposes, one could call it that, but no longer it is specific to a particular domain. It's a general purpose programming language now. So certainly not. So in the same way, whatever code that we are writing, one could see it as, hey, this is just a JSON, or they could see, hey, this is actually a scripting language in itself. It's a dialect in itself. And that needs to be now interpreted to an underlying program. Like in case of Python, you have a runtime. In case of any other language, you have some runtime at all points of time. Like you have a JavaScript, which also has a runtime. Now, everything is going to be interpreted in some manner or the other. Now, you are just adding one more layer to it and saying that we are moving towards higher order of abstraction, because every time I don't think it deserves to be written as from scratch. Like that's what SDKs are as well, actually, when you come to think of it, right? When you use an SDK, yes, one could say that, hey, but my code is actually going to get compiled, etc. So which is what I said, like that's a separate discussion. But so I wouldn't say it's a reinvention of an interpreter, but yes, the interpretation is needed for sure in any logic that is to be written.
Yeah. Next two questions were are the same. The programming committee came with. How do you test your DSL?
Lots and lots of events. All these events that have been coming in, every event with every variation is passed through a test harness. The good part is because it doesn't require a new build and only requires configurations, which is saying that there's a browser and there's a CSS. How do you test your CSS? A CSS is a configuration language on top, right? The CSS file that you write. You load it.
We don't test our CSS.
Yeah. So see, that's the problem of pronouns. When I said you, I meant one. So yeah. Anyway, so So testing CSS, similar challenge, like you load it, then in our case, there's a configuration. We pass it through the binary, the configuration languages on the top, the smaller configuration file. We run it against known events, and they should exactly produce the same output. And against unknown events, they should fail and fail early. That, hey, this is an event type that we don't understand.
Yeah. This might be a technical problem testing this, because you need some set of data prepared and
true. Obviously, yes, absolutely. I mean, but we know the data, right? Because we are domain specific here. So we know the domain specificity. We know the entire data set. So it's not that it's an unknown problem. It's the problem, which is what I'm saying, that if the problem domain is unknown, you need a general purpose thing.
Yeah.
If the problem domain is known and is limited, it's just the volume of the variety there, a known set. It's not an unknown set. It's still a known set, right? Like if you were to write something for integers versus float, think about it, right? There are only so much known integers in this world, but floating points is an infinite set.
Yeah.
It's the same problem. Testing anything against integers is fairly straightforward. There can only be so many. So I'm not talking about big int, I'm actually talking about a small int. There are only so many integers that you can very well test it. Even if you ran a for loop on it, you will be able to test it. So the knowledge of the domain is narrowed down because we know the specificities of it.
So the answer is keep your domain smaller.
Yes, I mean, if your domain is smaller, yes, do not try a DSL to become, hey, I'm going to solve every single problem in this world, right? Because that's not what a DSL is for. In fact, quite the opposite. When you have narrowed down that, hey, these are 10 things that I need to do, and these 10 things I need to do daily, these 10 things I need to do repeatedly, maybe, I mean, think of it, right? What is Chef? What is Ansible? A limited set of problem, it's a DSL on top, right? I mean, and these DSLs are around you forever and ever. Like, what is Chef? A known problem, 50 kind of things, modules that I need to load, and that's it. Do this over and over again.
Yeah. Another question, same as I have myself. Do you have IDE support for your DSL? Did you think about IDE support?
Good question. So actually not, because then we are drifting away to slightly say that, hey, it's not that vividly used where we actually need an IDE support, but we do have linters and a compile time check, which will say that, hey, this doesn't look okay.
Okay.
One very interesting question that I would like to add here, which I think nobody has asked and should have, how does this compare against code generation? Because that is one of in a language like Golang, right?
Yeah.
That could also be one of the options that, hey, why don't you actually generate some code? Because the limitation here is that this is still runtime, right? It's a JSON being parsed. So what that means is that there's a problem still of latent configuration error. What that means is that only when it's like what a Python does, right? It's a JIT. So technically it's a just-in-time compiler here, right? Because when it reaches that field and tries to extract that data, it may fail then. Now, all of this could be made better and faster if we were actually using code generation. So, but why did we not use code generation? Because at the start of the talk, I mentioned every new event should not mean a recompilation. If I was using code generation, I would have to recompile every time. And that is what we didn't want. So just wanted to clarify this because somewhere this is a worthy question of being asked as well, that, hey, what about code generation? Such amount of heterogeneity, but yet a limited domain set could have been very well easily be handled by code generation.
The next question is, did you think to adopt Kotlin DSL for your task?
No, I didn't actually. So
that's I'm not I don't know too much about Kotlin, so I don't know what does this question exactly mean.
I have one reason why that question I'm shying away from answering that.
Yeah,
it's a Golang conference.
Okay.
We can't be speaking about Kotlin here.
Okay. The next question, actually, a couple of questions. How long have you been using your DSL in production?
6 months.
6 months. Okay.
That's how old the company is. So yeah.
Okay. Do you keep backwards compatibility as it evolves? I mean, does running current version of parser on old config plus data still provide correct outputs? Are those outputs exactly the same?
Absolutely. So brilliant question. We haven't yet reached a stage where we have to, but we already have discussed plans to do this. So in which case, what we do is, see, here's the thing. The logic of parsing is inside our binary. Mm-hmm. It's like saying Python 2.7 mm-hmm. knows how to read your Python 2.7 code. It knows print space something means something. You run this code against Python 3.x compiler interpreter, it won't read this. It would raise a syntax error because it expects print and a bracket. Now, if you see what I'm trying to say here is that the logic of backward compatibility, the onus is actually on the rule set of the compiler. If we end up introducing changes where we say that, hey, this for do principle is completely nonsensical and we wanted a better construct, we will just launch a different binary of it, which will be the V2 of the same DSL parser, right? And that binary can produce the same output as we do today. Mm-hmm. So the backward compatibility doesn't have to be, and this is more of a design principle I'm saying here, that, because DSLs are so limited, you don't want to overload those with those plethoras of if-else conditions that, hey, this is version this is version that. What you should be doing is that, hey, this is a syntax that I just don't understand in the newer version set. So the configurations will also have to change with the newer logic set of the parsing that we introduce.
Actually, I have something to say about this.
Yes, please. Yes.
Once I was working with some financial tech company, and they were maintaining the stream of events happens inside of our system, and we were saving these streams of events, thinking as long then in the time we were lost our current state, we will be roll out the state from these logs of events we are keeping continuously. And once it happened, we lost our current state, our database, so we started to roll out this.
Replay, right.
And they stopped on the first 2 weeks data of this log just because in after 2 weeks of after start we fixed the bug, and the old events were not parsed correctly by our current version of software.
Right. I understand. Yes.
Yeah. So do you think you will have this problem once?
Absolutely, I will, certainly. And any long-term solution that you build will always have to go through this notion of versioning. In fact, it's not just the versioning of the source. Let me also tell you, it's the version of the output that we produce.
Yeah.
And when you produce an output right now, we actually add a small version number. Now, this version number that we emit is actually the version number of the binary that we had used, the parsing logic, because that tells us that, hey, this event that was parsed came out of version 1.2 and not version 1.3. Because if this output looks incorrect, we can quickly go back to version 1.2 of the binary and check that. Just that we haven't yet reached a cross-version jump where we say 2 versus 1, but these minor versions do exist in the output as well.
Yeah, we were thinking it will take for us about a couple of hours, and as a result, it took about a week for us, because we were looking for the problematic message, for the date of problematic message, for the corresponding commit. We were building the bigger and bigger binary to parse this. It was like a nightmare, actually.
Wow. What language did you use?
It was it was DSL specific, some very small language describing the things happens with the customer account.
Got it. So it was got it. Okay, so it was a DSL of that time.
Yeah, and the program itself was in Golang.
Oh, okay, nice.
Was in Golang. Okay. So, do we have another questions in chat? Probably not. So I can return to our own questions. Some of them already answered. Yeah. Okay, sorry. There is no time here for any more questions because we have 3 minutes till the next talk.
Oh, okay.
I'm sorry. Can we extend this to 10 minutes again? And Piyush, could you please go to the special chat, and people who like to talk to you, please talk to Piyush, please go to the special chat also. We will have the small gap between the talks. I insist we should keep another 10 minutes so you will be able to talk to each other. Thank you very much. Okay.
Thank you, Daniel.
Bye.
Yeah.